Here we have another optimization problems. Find the dimension of a rectangle with perimeter 100. So what is given condition? This is perimeter of a rectangle is 100, whose area is as large as possible. So what needs to be optimized is the area. Okay, so our function is going to come from area. First of all, we need a rectangle. What do we need to find? Dimensions of a rectangle. So usually rectangle looks like this. It has a length, it has a width. So dimensions meaning find the values of x and y. We need to find x and y. This is our problem. What is given? The perimeter. Perimeter is basically the boundary of the rectangle. So this is also x and this is also y. Perimeter is 2x plus 2y. This is given as 100. It is given to us. Okay. What will be the area of your rectangle? Area is length times width. So here in this case is xy. We need to optimize our area. Our function is going to come from area, but it's a two variable thing, right? We need to convert that into single variable. How are we going to do that? We are going to find y from here. 2y is equal to 100 minus 2x. Y is equal to 100 minus 2x by 2. Okay, so that means I can factor 2 from the numerator. 100 minus 2, sorry, when I'm factoring 2 out of the numerator, it will be 50 minus x divided by 2. 2 get cancelled. So y is basically 50 minus x. I will put this y here. That means my area is equal to x times 50 minus x. This is a single variable, 50x minus x squared, by distributing x inside. This is my function which I need to optimize. Once I have the function which I need to optimize, I can apply my calculus now. What does calculus say? Find the first derivative. First derivative is 50 minus 2x. Then find the critical points. Critical points come from f prime x equal to 0 or f prime x does not exist. We do not need to do does not exist. Why? Because this is a polynomial. So 50 minus 2x is equal to 0. 2x is equal to 50. X is 25. We have our critical point. Now we need to confirm that our area is large when x is 25. How do we do that? We use second derivative test. We find the second derivative of the function. Second derivative of this function would be negative 2, which is actually always negative. Negative 2 is always negative. Doesn't matter x is 25 or not. So we can say, using the second derivative, if second derivative is negative, the function is maximum at the critical point, which is 25. So f of x is maximum. What was f of x? Where did f of x come from? Area. So area is maximum at x is equal to 25. So we needed to find the dimensions. We already found x. X is good. How do we find y? Y can come from here. Y is equal to 50 minus x. X is 25 now because we found it. Therefore, y is also 25. Our dimensions are 25 and 25. At these dimensions, the perimeter is 100 and the area would be as large as possible. So that also confirms that our rectangle would be a square to be having maximum possible area.